Hello students. In the previous class we have discussed about the chapter that is motion in one dimension. In that chapter I have taught you about various topics such as those topics were like frame of references, concept of point mass, motion and rest, distance and displacement as such. And actually those topics are not there in the syllabus, which means that those direct topics will not be there in the examination, but the concept of those topics are required in the following chapters. So today we are going to start a chapter that is motion in a plane. This is chapter 5. The first topic which we are going to discuss is scalar and vector. Most of the topics in this chapter is related to scalar and vector quantities only. So what are those quantities, how we add, how we subtract, what are the rules, all these things we are going to study in this chapter. So first of all, we will discuss about what are scalars and vectors. These things, as you already know, scalar is a quantity which has magnitude, vector, magnitude as well as direction. This we have already known from junior classes itself. Now, scalar quantities example will be mass. Mass of an object, example, suppose you bring 10 kg of rice, that will be the mass of the rice, and it doesn't have any direction, so it becomes a scalar quantity. Another thing will be distance. Distance is a scalar quantity because if you travel from one point to another, the distance traveled will not be having any particular direction. You can travel in any sort of direction. That will be scalar quantities. Whereas vector quantities are those which have mass and direction and which also obeys the triangular law of vector addition. I will teach you those laws in the coming topics. Example of vector is velocity, displacement, weight of a body. All these things are vector quantity. Velocity is a vector quantity, whereas speed is not a vector quantity. Speed means, suppose a object is traveling from one point to another in any particular direction, so that will be the speed of an object. But if it travels in one particular direction, then that will be the velocity of the particular object. Displacement distance is also, suppose from point A to B, this whole path is the distance. If you directly see from point A and B, if you choose the shortest path, that will be the displacement, and direction will be from A to B. So shortest path is displacement, longest route is distance. Distance doesn't have direction, displacement has got direction. Okay, these things you already know. We'll move on to the general vectors and their notation. Vector notation. So vector notation, we require direction. So there are 4 directions: north, east, west and south. So in vector we need direction as well. Suppose there is a car moving with some velocity towards this direction, and there is another car moving towards upper direction. This is car B. Okay, car A and car B. Now, how do we say that? We look at the length of these two arrows. Okay, the length of A is smaller than length of B. So length represents magnitude. How big is the magnitude? How long is the, or how much is the velocity? So velocity of A is less than velocity of B because B is longer. Now the direction of A. Direction of car A is towards east. Okay, towards east direction. But velocity of B, okay, this is pointing not exactly towards north, but in between north and east. So velocity of B is toward towards northeast direction. So whenever we write in a vector form, A must be represented with an arrow on the top and B as well, because these things are vector quantity. Okay, you can represent A, or you can write over here OA. So your vector now becomes OA with an arrow on the top. Suppose this is OB, this becomes OB with an arrow on the top. Vector quantity should have an arrow on the top. So longer the arrow, greater the value of that particular vector. Okay, now classification of vector quantities. Vector quantities can be classified as polar vector, and there will be another type, that is axial vector. When the vector quantity has the well-defined starting point, then it is a polar vector. That means, suppose a car is moving from point A to point B in a particular direction. So AB is the displacement of the car. This has got a particular starting point. So displacement vector is a polar vector. Similarly, velocity. Car is moving from point A to point B with some certain velocity. So it has got a starting point. So this also becomes, velocity also is a polar vector. Force, all these things are polar vector. Now the axial vector. Axial vector is related to the angle. When a physical quantity represented by a vector is not confined in a straight line, but is described by a plane at least. Example, rotation. Suppose an object is revolving round a certain axis. Example, torque or your angular momentum or angular velocity. When an object is revolving around, that means moving in a circular path. The object is a vector quantity, but the direction of the object keep on changes. So how do we know the direction of this object? If the object is moving in this plane, okay, in this plane of paper in a circular motion, then the direction of the vector will be upward, like this. The direction of the vector will be upward. So this arrow over here gives the direction of the vector. Example, omega. Omega is for angular velocity. So this is omega in upward direction, gives the direction of an vector. This vector, when an object is moving in a circular path, is known as axial vector, or also known as pseudo vector. Okay. Now the next topic is position and displacement vector. Today we are just discussing the basic topics related to vector. Okay, so position and displacement vector. To describe the motion of an object in a plane, we use the concept of position and displacement vectors. For this, we select a point in a plane as origin. Suppose this is your Cartesian coordinate. This is y-axis, this is x-axis, this is origin O. So this is just a reference point for measuring the vector. Okay, for measurement we need this kind of coordinates. So the movement starts from O. So a vector, then suppose, okay, in this one, an object, first of all, at time t1, it moves from O to P. So this is represented by R1, or the vector R1, which is also known as position vector. Okay, this R1 is the position vector. Suppose there is another object moving from O to point Q. This is represented by R2. This is the position vector of OQ. There are two vectors, one is OP and other one is OQ. The vector PQ draws from point P to the Q is called displacement vector. So vector from O to P is known as a displacement vector. The time duration for OP is T1. Time duration for OQ is T2. Okay, this is T2. Suppose the difference of the vector, if you draw a line over here from P to Q, the difference between this PQ gives the difference between these two vector. Or if you subtract these two vector, what we get is we get PQ. This PQ is known as displacement vector. OQ, OP is position vector. PQ is displacement vector. Just a name given. So ultimately, what is PQ? PQ is vector R2 minus vector R1. Difference between two vectors is represented by a shorter vector over here directing from P to Q. This is position and displacement vectors. Now we'll also discuss about the zero or null vector. Zero or null vector. Suppose we have two vectors A and B. Both have got same magnitude and same direction. So when they have got same magnitude as well as same direction, if you subtract this, what we get is we get 0. It's like subtracting the same number. What we get is 0. But this 0 is not only 0, but it is a 0 or a null vector. The condition for this should be A should be equal to B. Zero vector is a vector of zero magnitude having no specific direction. So this doesn't have any direction, no magnitude as well. Its initial and terminal points are coincidental. So just like in the previous case, if there is a vector OP, this is represented by A, another vector overlapping this vector is B. Suppose these two are the same vectors. There are two different vectors at the same starting and ending point. In this case, if you subtract this, what we get is 0, which is a null vector. In the condition should be these two vectors should be equal in magnitude as well as in same direction. Now the properties of null vector. Okay, properties of null vector. Number 1, the sum of a finite vector A and a zero vector is finite vector. Suppose there is a vector A plus a 0 or a null vector. What we get? Finite vector. Number 2, the multiplication of a zero vector by a finite number. So if n is a finite number, any number 1, 2, 3, 4 into null vector will give you the null vector or the zero vector. Another one is the multiplication of finite vector. Suppose A by a zero vector gives you a zero vector. So the three rules for a vector or a zero or a null vector. A zero vector does not quite fit in our description of a vector as it has no specific direction. In this way, it is considered as one of the non-proper vector, even though it is needed in vector algebra due to following reasons. So why do we need vectors? The reasons are, suppose the question is, what is A minus B when A is equals to B? So if there are two vectors A minus B, what do you get? What do we get ultimately if A is equals to B? We get a zero vector. That will be the answer. Suppose another question. Suppose if it is, what is A plus B minus plus C? If these vectors form a closed figure, suppose there are three vectors forming a closed figure, then what do we get? So this is A, B and C. What do we get? Finally, we get a zero or a null vector. So for these reasons, we need zero vector, a term known as zero vector. Another question is, what is the displacement vector of a stationary object? So if an object is stationary, so how much will be the displacement vector? If an object is at point A, it is not moving anywhere. So what is the displacement? Displacement is 0. But because displacement is a vector quantity, this will not only be 0, but this will be a 0 vector. Now, the last topic for today's discussion is equality of vectors. When and how the vectors will be equal. Example, there are 4 vectors A, B, C and D. Okay, A, B, C and D. So over here what we can see is A, B, C are in the same direction. Magnitude, the length of this arrow are also same. So in this situation, A is equals to B is equals to C. These three vectors are same. Whereas D is also same in magnitude, but the direction is opposite. So D is actually equal to all these three, but direction is opposite. So we will write a minus sign which represents the direction. So ultimately A is equals to B is equals to C is equals to minus D. 3 vectors are same with same direction. One is same but with opposite direction. So minus sign represents the direction. Or this is also known as negative vector of the original vector. So for 2 vectors to be equal, the magnitude and the direction has to be equal or same. So these are the basic ideas of vector addition. In the next class, we will study about adding of vectors using specific rules and subtraction and multiplication of vectors. So this much for today.